Hey guys, so in this video we are going to talk a little bit about refactoring. So let's get into it. Now, refactoring is a very popular term that people throw around whenever they see some code that they don't really like. And this is not a talk about when you should refactor or what you shouldn't refactor and best practices and all that good stuff. This is more a talk about something that I found the other day. So I was working on a particular ugly piece of software that was very messy. It was very tricky to figure out what was going on, and what was even worse, it was a high risk area. What do I mean by a high risk area? A high risk area, per my definition, is a piece of software that is critical to the system as a whole. In this case, it was the authentication system or the authentication modules, which means that if anything goes wrong here, if I make any type of mistake that causes an issue for this code, the whole system is compromised. This is not just one little feature somewhere. This is one of the backbone parts of the system. And you've probably heard me, if you've watched any of my other videos about this, talking about how if you have a bad backbone or stem or keel or whatever you want to call it, in the system, it affects absolutely everything. And this is still very true, which means that now I'm in this good, nice, tasty position where I can do one of two things. I can either try to make this code nicer and try to fix things and try to improve them, or I can shim something in. I can do shim programming. And let's talk about that, because you might get it into your head that just because I'm an advocate of clean code and that I think that you should always strive to do the best work that you can, that I would go with option 1. But I didn't. I went with option 2. And let me explain why. You see, at the time, I'm pushing a deadline. Basically, that's the situation. I have a finite amount of time to solving this issue before my boss comes and asks me a question about why aren't you done. And although it is true that I could take the risk of creating a severe regression bug and fix this and refactor it, because once again, I remember, if I get it wrong for any reason, the whole system is compromised and I have to undo what I've done anyway. And most likely, in my experience, what happens is that if something is so complicated that you get it wrong in a refactor, odds are that you simply revert the changes, and either you spend a lot of time trying to figure out what regression you introduced, or you simply let it be and you just move on. So with these restrictions, you make the decision to do shim programming, where you shim in the feature that you are trying to get in there, basically, without actually refactoring the code. So when you make that decision, you make it because you realize that although you want to improve things, you don't have the time, you can't take the risk, and the cost-value ratio is off. It's actually better for you to try to shim something in than it is to fix things, at least at this point in time. Unfortunately, although you don't want to, you have to. So how do you do it? How can you possibly mitigate this problem? This is basically damage control. It's basically you trying to figure out how to make to choose the lesser evil here. So what do you do? Well, let me explain. So, the way that I think about shim programming is this: library-oriented programming. What do I mean by that? Well, I mean that when you are making a conscious decision to simply add to an issue that is already growing, in other words, this ugly code is getting even uglier, the best thing, as far as I'm concerned, that you can go for is isolation, code isolation. So in this very specific scenario, what I needed to do was basically to latch on an event system to the existing code. I needed to create some database records, etc., etc. So what I did was simply to create a separate service, or a module basically, that did all of these things that I needed internally. I created an entire separate library that did everything that I needed. I didn't add any logic whatsoever to the problem area. In other words, I didn't start adding private helpers, anything of that nature, to the problem area. In other words, the authentication code. I created an isolated class, an isolated service that knew everything it needed to do the thing that I wanted to do or add to this ugly piece of code, and I isolated it. And the total amount of changes to the problem area was 3 lines of code. 3 different method calls in 3 different methods on the problem area. That was the total shimming or impact that I added to this ugly piece of software. But the code that I wrote was unit tested, integration tested, and in a completely isolated area with actually a little bit of documentation even. So I tapped myself on the shoulder there and felt really good about myself. And then I pushed it and I was done. Why is this important? Well, I spoke to my colleagues about it, and we agreed that although we would like to change this and make it a really nice implementation, we simply can't take the risk at this point. So when we are faced with no other option, doing shim programming in this manner is the way to go. Because when you think about isolating the functionality that you're adding, when you want to change, or when the day comes when you need to refactor this thing, when you roll up your sleeves and you say, hey, today is the day, we're gonna fix this damn mess. It is very easy for you to feel confident that the features that I added in this scenario are going to stay intact. Because the amount of code that was added to the problem area is very isolated, is very tiny. The impact area is very small, and the feature itself is isolated from everything else. And that's what I want you to take away from this. If you start thinking about the code that you are adding as a library, just think about it yourself. When you refactor your project and you have tons and tons of dependencies, if you've done things correctly, if the library that you are depending on is this isolated thing that works as a separate entity from everything else, it's very easy for you to port these things around, to move things around in your system, because the impact area, unless you have like a web framework or something where the web framework is usually tied into absolutely everything. But if you have these tiny libraries that are isolated, it's very easy for you to change things. And that's, in my opinion, what you should go for if you need to do shim programming. Add isolated code that is easy to change. Have a great day.